Thanks everyone for coming. If you just are trickling in. I am going to talk about, oops, okay. I am going to talk about a format that I created called PMTiles. It's come up in a couple of presentations already at this conference. And I kind of gave this talk an abstract title called MP3s for the Earth. But it's basically about like why cloud native geo is not really about software, but it should be about formats. Uh, so quick intro to what PMTiles is in one slide. It is a tile archive format. So it does not store entire features. It splits them into tiles. And that is specifically for visualization in multiple resolutions. So for making things like Slippy maps that you can zoom and pan around. And PMTiles is an open spec in the public domain. You can think about it a lot like cog for vector. I feel like that's a pretty useful angle that more GIS or raster focused people are familiar with. It uses a lot of the same techniques for visualization, like overviews that cog does, but uses vector tiles. It can also store raster tiles, but most people use it right now for vector. And it's designed to work on S3 object storage and also to be read directly from browsers with no intermediate server or Lambda in between. You can add those, but it's a design constraint to make it possible to read directly in the browser because that's the most useful to the audience that PMTiles is serving. It uses a compressed encoding of the spatial index and also just tiles in general, like PMTiles, are focused on visualization and are not really appropriate for doing analysis, like doing a statistics or doing counts of features. So to give you an idea, I wrote a blog post last year about PMTiles on the CNG blog that explains this more about why you might want to use tiles and when you might want to use something like GeoParquet. So a quick 2x2 is if you think about raster in the top, there's GeoTIFF and cog, which are good for both analysis and visualization because they're raster. But for vector, you have these analytical formats like GeoParquet, flat GeoBuff, but those are often unwieldy to visualize because the data size is large. So to build overviews, people generally try to use tiles, and that's what PMTiles is for. So who uses PMTiles? A lot of GIS companies, Earth observation. In the public sector, if you are building internal maps or maps for the public, it is a great way to publish data with open source tooling. Even individual developers, hobby developers, and the entire spectrum. So it is not really just for hobbyists. It is not really just for enterprise. It is for a wide range of use cases. So some showcases of who's using it. There's a great project called the National Zoning Atlas, which is a interactive analysis of zoning laws like around the country in the US. This is all built with PMTiles for these overview and base map layers. The Overture Maps Explorer, which has several hundred gigs of data, you can interactively explore this data set on the web. And that is just a public PMTiles file they put on S3 that powers this entire website. So I want to get into the meat of this. Okay, one last slide is showing the growth in adoption of PMTiles. Now this is like npm install, so it might just be a bunch of automated GitHub actions, but it's grown quite a bit in the past year. So you can see kind of this general trend upwards to where it's being downloaded about 30,000 times per week. So I hope this keeps growing. It seems like it's picked up some audience in the past year. So getting to the meat of this topic, which is, so I talked to a lot of FOSS4G people about PMTiles, and I get a lot of questions and pushback. Some of the questions I get are, why don't you just use some server software that already exists with, let's say, PostGIS? Like, doesn't that solve this problem already? Like, why do you need to invent a new format? Or it's a static, it's a total, like it's a static archive, and they think, oh, like that's wasteful. Why not just do it dynamically? We have maybe a SaaS product where you can just point it at your raw data, and then so you can just pay us to solve the problem. maybe that's more efficient. I don't know. That's one kind of pushback I get. Cloud storage compared to servers is slow, and you have to pay for the storage, so it's a ripoff. Like why let Amazon rip me off when I could just rent a bare metal server somewhere? My favorite one is you're not going to make any money doing this open source stuff, and like like this model doesn't make sense. Like why develop this? And the way I kind of think about this is comparing it to MP3 files for music. So MP3s are an audio format that was invented in the 90s. And the sort of, I guess, marginal breakthrough of MP3s was they used a compression algorithm that was based on perception. So it took away, it was lossy, it took away some parts that humans couldn't hear. And that achieved a roughly 10x reduction in the size of music files compared to lossless ones. And the quality was not perfect, but it was good enough for most of the music people listened to. And the other big part about MP3 was that it was open. It wasn't perfect. There was some patent issues that lingered around MP3 for decades, but this allowed a proliferation of commodity devices to play back and to store MP3 files. And that's really what changed the music industry was this open format that was very easy to distribute and to store and to share. And what impact did MP3s have? Well, so MP3s were an innovation that was at first rejected by the industry because storing and sharing music this way was counter to the business model of selling CDs. If you are a music exec, you're not interested in MP3s because like you don't want to make it easy for people to download music. So you want to make it easy to buy music on a CD where maybe you have like 12 tracks on a single record. Um, but the value chain of MP3s got turned upside down by this ease and accessibility of music. So the way I want to frame this is that we're still in the compact disc era of geospatial. Because creating CDs, so just like creating global maps or data sets, requires economies of scale that are accessible to very few companies. Like let's say ArcGIS or Earth Engine, those are a very limited number of producers. But if you change the underlying technology, then then it becomes accessible to publish and to remix and to share for everyone and not just a handful of companies. And those companies, they have misaligned interests. They're not really interested in commoditizing this stuff. So I think cloud native geo has the potential to be sort of the MP3ification of the geospatial industry, for better or for worse. Some business models might become obsolete, but there might be some new ones. So S3 is like the iPod of geodata. It's the most commoditized platform that everyone knows how to use. You can kind of get it affordably anywhere. And that's also what is sort of the base that PMTiles is built on. So if cloud native geodata ought to be as easy to share, remix, and preserve as music, then that needs to be supported by the libraries and by browsers. So I'm going to talk a bit about the details of how that works with PMTiles. So for comparison, on the web, there is an HTML video element where you can just point that at a static video file like an MP4, and it uses HTTP range requests to read parts of the video, and that's standardized in the browser. So how I imagine geodata can work is on pmtiles.io, you can just click a file hosted on Source Cooperative and you can zoom and pan around, and there's no server in between. It's just a file like a movie or like a music file. You can embed, so just like an embedded player, there is an embedded PMTiles viewer on Source Cooperative. Even on your local computer, so it doesn't have to be on the cloud. It could just be on your desktop, but you can drag and drop just like playing a video file in VLC or something. And importantly, you can even use it offline. This is at the SFO Airport Terminal 2 Sky Terrace, so if you have a layover there, maybe if you want to go check this out. So Aaron built a offline PMTiles viewer for the airport. It's the museum exhibition. So it's not necessarily on the cloud, but it is this simple format that is portable anywhere. So if the map is just a video, then we need to make sure the software all works to do that correctly. Part of that design for video that I'm also using is related to e-tags. This is how it detects when a file changes on storage. It sort of hashes the file so you know like the content changed. This is supported across the entire PMTiles reference implementations now. Just a diagram of how that works. If you make a request for a blob for a range, and the e-tag changes, then the JavaScript client will detect that hash change and then do like a retry. So this sort of works like it just works. So you can embed a PMTiles in a file, the URL, and then you can update it, and like the software will cache bust correctly, for example. So in conclusion, let's move beyond the compact disc era of geospatial. I think that's what we're all here for. And thanks to Radiant Earth for their tech fellowship that helps me work on open source full time. You can upload your PMTiles right now to Source Cooperative and take advantage of all this. And if you have questions, you can email me, brandon@protomaps.com, or find me on Slack. And that is the end. So I hope to see you online and at the rest of the conference.